now we are going to see how to construct the finite automata. So finite automata, definition of finite automata is five tuples that are q comma summation comma del comma q naught comma f. So q is a finite set of state, summation finite set of input, delta transition function. So transition function is nothing but q into input equal to transferred state. Q naught is the initial state, f is a final state. There are two types of finite automata. One is deterministic finite automata, that is DFA. Another one is non-deterministic finite automata, that is NFA. So here we are going to see how to construct the deterministic finite automata. So steps to follow to solve the problem is: first, write the possible strings. Second, draw automata for condition. Third, convert it into maximum string. So the first problem is draw a deterministic automata to accept a string contain 0, 1, 0 as a substring for the binary input. So first binary input is nothing but 0, 1. So first step is possible string. Possible string. So W equal to, so the first possible string is what is the condition given in the question is the first possible one. Suppose 0, 1, 0 is the first possible one. So it is the substring in anywhere of the automata. So next, in front we have n number of zeros. So 0, 0, 0, 1, 0 or 0, 0, 0, 1, 0. Same as in front we have n number of ones. So 1, 0, 1, 0 or 1, 1, 0, 1, 0. So similar in the back side n number of zeros. So 0, 1, 0, 0. N number of 1 also 0, 1, 0, 1 and so on. So these are all the possible string for the given condition. Second, automata for condition. So for the condition is 0, 1, 0. So for n number of input, n plus 1 number of states. So if there is 3 input, we have n plus 1 state. So Q naught, the first input is 0. Then Q1, the second input is 1. Then Q2, the third input is 0. Then Q3. Here Q0 is the initial state and Q3 is the final state. For the condition, we have to draw the automata. Initial and final does not change for the maximum one. So this is the minimum condition possible for the automata 0, 1, 0. So next, third, we have to convert it into the maximum string. Maximum string is nothing but it have n number of zeros in the front or n number of 1 or n number of zeros and ones, combination of zeros and ones in the front and back. So this is the maximum string condition. So first you have to draw that minimum one. So Q0, 0, Q1, 1, Q2, 0, Q3. So next, for every state we have to check what the input transferred and what is the balance input and how we have to transfer it without change the condition given in the question. So first state Q0, the input is 0 transferred, balance one input is 1. So we have to check where we have to transfer the 1. It does not change the condition 0, 1, 0 as a substring. So first if we have to give 3 possibles. So first one, forward transfer. Second one, self loop. Third one, backward. So first q naught 0 is transferred, balance is 1. So if we give 1 to the q1, the substring is 1 1 0. So it does not satisfy the 0 1 0 substring. So for q2 1 0, for q3 it transferred to 1. So next possible is self loop. If we give q1 q naught for 1 as a self loop, 1 0 1 0 to the final state. So 0 1 0 substring is there, so the condition will be satisfied. So q naught for 1 is a self loop. Next q1 the input is 1 transferred, balance 1 is 0. So if we give forward to the q2 0 0 0, so 0 1 0 substring is failed. So if we give to q3, it transferred 0 0. So if we use a self loop 0 1 1 0, so 0 1 1 0, so here also the substring is failed. So if we give to the backward to q naught 1 0 1 0 1 0, so anywhere the substring 0 1 0 will be retained in the automata. So first forward it is failed, self loop it is also failed, for backward it have the substring 0 1 0. So for q1 1 is transferred to q0. Next q2, so q2 here 0 is transferred, balance is 1. So if you give 1 to q3 0 1 1, so substring 0 1 0 is not there. So if you give to next option self loop 0 1 1 0, so 0 1 0 substring is failed. These are all the possible way how we went from initial state to final state. So self loop it is also failed. So next backward we have two possible, q1, another one is q0. So if we give to q1 0 1 1 1 0, so 0 1 0 substring is failed. So if you give to q0 1 as a transition 0 1 1 0 1 0, so anywhere we have to see the substring 0 1 0 when we have to reach the final state. So for q2 1 is transferred to q0. So last q3 0 and 1, two inputs are balanced. Already we satisfied 0 1 0 to reach the final state. So we have to give 0 1 as a self loop. If we have a front and last position has like this substring only, we have changed in the front and last. Otherwise the balance input will be a self loop one. So the given condition, the string contains 0 1 1 0 as a substring for the binary input, 0 1 automata is this one. So and then we have to write the definition. So definition, first one state, we have 4 state, q0, q1, q2, q3, then input is 0 1, then delta, then initial state is q0, final state is q3. So for each state we have to write the delta, del of q0 0, del of q0 1. We have two input. So q0 0 we went to q1. For q0 1 we go to q0. So for this we have to write the remaining state also. Thank you.